The next example that we're going to do is the other guided example on the front page, which is example 3. So I want to obviously start with kind of looking at what are some of the pieces that have been filled in for me, and maybe what are the connections that I'm supposed to make, because momentarily you're going to be asked to work on these even examples independently. So as I look, I want to notice several things. Number one, that the y squared is first, and I want to make the connection to the fact that that means it opens up and down. Okay, and so if it opens up and down, we want to remember that we would label that with a name, and that this would be a vertical hyperbola. Okay, because it opens up and down, and that's because the y squared is first. Next thing I might want to investigate is that the y squared and x squared don't have any shifts connected to them, because there's no subtraction or addition to the individual squared components, so that's where I'm getting my center of 0, 0. Having said that, I might choose to put my axes on the graph. I want to remember always that if for any reason my graph doesn't fit, I would need to perhaps reallocate where my axes were, and that's the flexibility of drawing them in yourself. Okay? So I can put my center on there. Again, we can use an open circle since it's not a point on the real graph. Now, what I want to do next is probably have a little bit of connection to what my A and my B values are. So if I need to, I could put this over a 1 because I just want to see it maybe looking like the other equations that we've investigated so far. A squared is always first in a hyperbola, meaning that this value underneath represents my A squared quantity. So if A squared is 49, I can get to an A value of plus or minus 7. That leaves my B value to be B squared is 1, so B would also be plus or minus 1. So now, as I'm going to graph, I want to remember a few things. If I'm having trouble remembering what A and B are as definitions, then I really might need to spend some time putting these definitions back together. Now again, this is for an ellipse. If you're accidentally seeing this relationship, I'm focusing right now on these definitions for A, B, and C. So A is distance from center to vertex, center to co-vertex, center to focus. So the way I like to think about it is they all involve the center. If you were thinking about the words vertex, co-vertex, and focus, I would say vertex sounds important. It uses the first letter. Co-vertex sounds less important, so it uses the next letter. And focus has a C in the middle, and so C is our last thing. Somehow or other, we've got to find a way to get these definitions into our head soon, if they're not already there. So when it comes to a graphing standpoint, I will move, let's see, since the 7 and the 49 are basically underneath the Y, that tells me I'm going to graph in a Y movement. So I want to count 7 up and 7 down. Now as I do that, because these are vertices, I could label them. I certainly want to make sure that I recognize and remember which ones are more important. Now these are my co-vertices, so I'm making them an open circle. Now as I go to make this guide box, in this case I'll choose a different color just so it's a little bit easier to see. The guide box is going to be very thin and tall in this case. I want to remind myself that this opens up and down, so in a minute we're going to make sure that we're putting the branches in the correct sections. So as I am drawing the asymptotes in, I'm going to try and do a stronger job this time to make sure that it both hits the two corners as well as the center. So as you do this, again, the more that you practice and use an actual ruler, it will be even stronger. Ms. Olson is currently using just a guide piece of paper. Do the same for the other asymptote. You'll notice again that it goes, both asymptotes should go through the center and respectively through their corners of the guide box. So as I'm ready to kind of finalize my graphing piece, I want to remember that these co-vertices are not listed, so this is correctly done. The vertices are listed, so we want to make sure we write those. The radius doesn't apply to a hyperbola, so we leave that blank. We want to make sure that we graph it since it was told to us that it was vertical and that it opened up and down, we want to put that hyperbola branch. You have one opening up and you have another one down here opening down. Now these might even look like mini parabolas to you. They're not, but they certainly have that appearance from your perspective as a student who's learning this early on. So we're left with needing to find the foci and asymptotes and kind of justify those numerical answers. So you're going to set up the relationship, and again, I'm going to encourage you to write down that focal relationship every time. Don't jump to just putting numbers in it, because that will not communicate to Ms. Olson what you think is happening. Again, since this is a subtraction, when I start to write down my focal relationship, I want to make sure that I use the opposite sign. Okay? So this is actually the Pythagorean theorem for a hyperbola. So a squared, remember, was first, b squared is second. Now, when I go to break down the square root of 50, we have the option of simplifying that into 5 root 2. If you're having any trouble with that simplification, message Ms. Olson privately so she can get you a couple extra examples to help you through that piece. Now, the last thing that we need to do is to talk about these equations for the asymptotes. So I want to start with my point-slope form. Again, won't hurt you to kind of practice that piece. Don't forget that that slope needs to have both the positive and negative. Now again, since my center is at 0, 0, I might find myself able to kind of skip a little bit this second step and go straight to the final version. But I'm going to count my slope is up 7 over 1, so plus or minus 7. And since it again is 7 over 1, I can write it the way it was in the box, but there's really no reason to go to that effort. If you wanted to just simplify it without writing the denominator still, this idea down here of having y equals plus or minus 7x is certainly acceptable.